Hi, this is Mr. Eaton, and today we'll be looking at applying Pythagoras' theorem. But before we get going, let's do a little bit of revision. Here is a right-angled triangle with a short side being 6, another short side being 8, and the hypotenuse being c. See if you can solve this to find the value of the hypotenuse. Put the video on pause and come back when you're ready. Alright, well, this is Pythagoras' theorem, c squared equals a squared plus b squared. We need to find c, so we're going to go with 6 squared added to 8 squared, and 6 squared is 36, and 8 squared, 8 8s are 64, and if we add those together we get 100, and therefore c is the square root of 100, and therefore c is equal to 10. So the value of c is going to be 10. If you didn't get that correct, I suggest you go back over the last 2 videos and do a little bit of revision. Alright, let's apply Pythagoras' theorem to this problem over here. We have a building that we don't know the height of, so this is the 3rd floor. We don't know the height of the building, but we do know how far away from the building the ladder is, and we also know the length of the ladder. So the question is, what is the height of the 3rd floor window over here? Put the video on pause, see if you can figure it out, come back when you're ready. Alright, well, you should have had Pythagoras' theorem written out like that. I'm going to rewrite it so that I can find the value of h. So I'm going to go h squared equals c squared minus b squared. And c squared, I know the hypotenuse is 10, so 10 squared. Subtract 5 squared, so that's 100. Subtract 25, and that gives me a value of 75. And therefore h equals the square root of 75, and that equals 8.66 meters. Therefore the height of the building over here is actually going to be 8.66 meters, and that's to the 3rd floor. Alright, well, here's another example to work on. Over here we have a tower, and it is 20 meters tall, and we have a moat that goes around the tower, and that is 50 meters wide. What we need to do is we need to make a zip line from the top of the tower all the way down to the bottom of the tower so we can escape. So the question is, how long is the zip line cable from the top of the castle to the bottom of the land? Now we can also assume that this over here is 90 degrees, and using Pythagoras' theorem we should be able to find the length of the zipline cable. Put the video on pause, give it a go, come back when you're ready. Alright, well, I've shrunk my picture down a little bit, but you should have Pythagoras' theorem, c squared equals a squared plus b squared, and I'm looking for my hypotenuse, so obviously it's going to be c squared, and we need to do a squared, which will be 50 squared, plus b squared, which is going to be 20 squared, and that will give us 2,500, add 400, giving us 2,900 meters, with the square root of 2,900 ending up to be 53.85 meters. So the length of the cable from the top of the castle all the way down to the land must be 53.85 meters. Obviously that is rounded to 2 decimal places. So there you can see 2 little examples on how to apply Pythagoras' theorem to problems that you may encounter.